and unmute.
Hi, everyone. Welcome to Grayscale's deeper dive into DeepBook and Walrus. Thank you, everyone, for joining. I am delighted to be joined once again by Adeniyi Abiodun, co-founder and chief product officer of Mysten Labs, the company behind Sui. Today, we're going to dive into two foundational projects in the Sui ecosystem, DeepBook, which is Sui's native liquidity layer, and Walrus, global data layer for on-chain builders. These projects are essential for enabling performant, user-friendly, and fully decentralized apps across DeFi, gaming, social, and enterprise. As always, the purpose of these is to introduce investors to the projects underlying our products, to make them more tangible and help them understand that what these projects can unlock. So before I hand it over, I need to read some disclaimers. Bear with me for a few minutes while I do that. This call is for informational purposes only and is not intended to be, nor should it be construed as or used as investment, tax, or legal advice, an investment recommendation, an IRA provider recommendation, or an offer to sell or the solicitation of an offer to buy any digital asset or security. Clients of Grayscale may maintain positions in the digital assets discussed on this call, and any opinions expressed throughout this webinar are solely our own and do not necessarily express the views of Grayscale or its affiliates. With that, I am very excited to hand it over to Adeniyi. Let's just kick it off. Can you give us some background on yourself?
Yeah, my name's Adeniyi. I'm one of the co-founders of Mysten Labs. My background is quite diverse. I started off as a software engineer in the banking space and found out about crypto in 2012, got involved in the Bitcoin space. Fast forward in, when Facebook were working on Libra, I joined the Libra team, working with Evan, Sam, George Costas, all my co-founders who are co-founders of Mysten Labs today. And we were actually at Facebook working on amazing technologies to make sending money as easy as sending a message on WhatsApp or Google. Make it free, ultimately. That was our goal. But while we were in there, we actually saw an opportunity to do something larger. We felt the internet was largely fragmented, and there was a distinct opportunity to build a new rail, what we call the new stack for the internet. Applications generally don't communicate well with each other within their bounds. And we saw if we could solve that problem, we could build a multi-trillion-dollar industry in that sense, where you literally liberate developers to build applications that are more composable with each other. So leaving Facebook, our goal was to continue the Libra mission in building a layer that makes it easy to send money as easy as sending a message, but also build this amazing stack that would allow developers to build new level of businesses that aren't been possible before.
Great. And I think you just touched a little bit on what inspired Sui. Anything else? Do you want to just give people a quick refresher on what Sui is?
Yeah. So Sui is what we call a global coordination layer. Traditionally, applications use APIs to communicate with each other, and that's fraught with a lot of friction. And in fact, a lot of problems have been created because users end up becoming the glue that stick apps together. What Sui is effectively becomes that glue. It allows applications to communicate with each other without the need of pointless APIs, but you can build amazing, resilient, decentralized applications on top of that. You can use it to coordinate payments, you can use it to coordinate websites, you can use it to coordinate data. You can effectively use it to coordinate application-to-application communications at a scale that's never been seen before. Some may call it an L1, but I put it to you that Sui is a lot more advanced than just the basic L1s you hear today. It has horizontal scalability. It doesn't have a finite throughput. Just like we build search at Google and our team built infrastructure at Facebook, it's built to dynamically scale. As you need more capacity, you throw more hardware, and you can pretty much get unlimited throughput with no increase in latency. It is a proper developer platform at scale.
And how, so to get to the next, you answered how sort of Sui sets itself apart. How do you guys do that? Is there anything else you want to share with people without getting super technical, and how the architecture allows you to do that?
Yeah, I mean, by way of contrast, Facebook has the same number of developers and they are in the entirety of Web3, right? So we're not building for a very small audience, right? The developer platforms we built generally are used by millions of developers. For example, JavaScript has over 9 million to 10 million developers. So we've literally built a programming language, what we believe is, this was developed by Sam while we we're at Facebook, called Move. And it really is going to be JavaScript of the new internet. And the difference between SWE and other technologies, ultimately, especially us at Mysten Labs, is that developers are able to pick it up very, very quickly. It's very adjacent to what they're accustomed to building, whether they're writing in JavaScript or C# or whatever. They can pick it up within 3 to 4 days and become very, very fluent and start to build really interesting applications very quickly. You contrast that with other platforms, which are very, very laborious and very hard to build on. So the ease of use and the developer friendliness is something that's really allowed SWE to grow its dev base faster than most chains in the last couple of years.
And there's also some characteristics of the architecture that allow you to be so high throughput and so fast too, right?
Yeah, so SWE is intrinsically built to be a parallel processing machine. So we don't process things in just the normal sequential way. We enable developers to take advantage of parallelization with the object model. So one transaction that has got nothing to do with one transaction can be processed at the same time as fast as possible. So you effectively have what you really should be getting today, really high scalable, really resilient systems, but that can process transactions as fast as possible in parallel without relying on queuing systems that traditional blockchains are restricted to.
And you're able to do at the same time what other blockchains have to do, basically like one at a time.
Correct. We do it faster, we do it cheaper. SWE's actual time to finality is about 390 milliseconds. Optimistic finality is in the 20 millisecond range. So that contrasts that with Solana, where real finality is in the 13-second range, in Ethereum, which is a lot longer. So SWE's orders of magnitude faster in terms of real finality than majority of chains in the ecosystem. It's actually the fastest chain that exists today on throughput and, more importantly, latency.
Okay, great. So we've covered SWE a little bit and what sets it apart, allows it to be so fast, so high throughput. Let's zoom in a little bit on the projects that we're going to talk about today. What led Mysten to focus on DeepBook and Walrus as the key pieces of the SWE infrastructure? And what were the pain points that people were experiencing that led you to do that?
Okay, I'll start with DeepBook, right? DeepBook basically, the TLDR is, it is a centralized trading experience at the speed of on-chain. Think of it as the NASDAQ exchange on-chain. DeepBook is an on-chain central limit order book. Just like securities are traded in legacy financial systems, DeepBook allows efficient trading of assets on-chain using the same speed and scalability that's afforded to you with SWE. Now, Walrus, SWE's already made it a lot easier and cost-effective to store data on-chain. But what we found were developers wanted to store larger things. So they wanted to store larger files, videos, petabytes of storage requirements. That's not something a traditional blockchain does really well. So it inspired us to really build Walrus. It's a decentralized storage space. It's not seen much innovation in the last 8 years, right? Like Filecoin is 11 years old. Arweave is 8 years old. Greenfield is captive within BNB ecosystem. Our research team had greater ideas on how to build a real infrastructure that made storage programmable, but also had amazing access controls, which you don't get with traditional public infrastructures. So it's built like the enterprise would have built it, but more for public markets.
Great. Okay, so let's start digging in. Let's do DeepBook first. And let's just talk about a little bit more what DeepBook is, how it's different from AMM-based protocols. I know there's a lot of problems that have been coming up with AMMs, and take it from there.
Sure. So DeepBook is a central limit order book. We'll call that a club, right? While AMMs are great for really long tail assets, highly liquid prime assets are better served on traditional order books, which offer better price efficiency and reduce slippage, more efficiency as a whole, right? AMM require a lot less bandwidth, which is, Ethereum is quite slow and most chains are generally quite slow. AMM is a mathematical way to try and solve the problem. You do have a lot of trade-offs there. It's great for low liquidity assets, but for really high liquid assets, you need a high bandwidth, high performing chain. DeepBook solves that because it runs on SWE. It benefits from SWE scalability and can trade way, way faster than traditional AMMs, but also offer better price discovery than you can get on AMMs. It's really where the world needs to go, but it's uniquely enabled by SWE.
So you're bringing institutional caliber trading infrastructure to DeFi. And
that's true, yeah.
And how do you, in building this on SWE, how are you taking advantage of SWE's unique architecture to do that?
Yeah, so DeepBook actually leverages SWE's object-centric architecture. It separates each market into independent shared objects. This design means that, for example, a SWI USDC paired is going to be sequenced in parallel with a deep USDC or Bitcoin and USDC, or let's even say gold and USDC, because you can trade gold on SWI on DeepBook now. It enables true scalability, which is something clubs and other chains have struggled to handle. In traditional chains, I'm trading one asset, but I'm trying to send a transaction. But if a particular club is busy, everybody has to wait. So two transactions that got nothing to do with each other somehow end up being related in traditional blockchains. SWI has parallel lanes, so it doesn't have that same congestion issue.
And how does it compare? So for instance, when I go on chain and I'm, trading on AMMs, how is the experience different as it relates to latency, slippage, and the overall interface?
So DeepBook now delivers less than 2 basis points of price impact on $10,000 trades. And currently it processes more USDC SWI volume than any centralized exchange other than Binance. That's huge, right? So more than most centralized exchanges, DeepBook actually processes more volume than centralized exchanges. Combined with its fast-finality, trading on DeepBook is really converging towards a centralized exchange experience, which is what the goal ultimately was.
That's really impressive. Yeah. And I think you kind of covered this, but is there anything else just around the institutional grade experience that you've all built that you haven't covered? Anything else you want to share on that?
Yeah, so the first thing is over 2 million in depth inside a 100 basis point spread. Execution is actually competitive. So what you're finding actually now is people are doing arbitrage that usually would happen between decentralized exchanges and AMMs. People are now able to do that arbitrage directly on chain because SWI has this mechanism called programmable transaction blocks, where I can pretty much transact up to 1,024 transactions in a single submission and do that instantly with atomicity. So DeepBook recently reached an all-time high in daily volume. It's hit over 42 million and outpacing several centralized exchanges. You're finding that arbitrage is now starting to happen on DeepBook, where before it used to happen directly on centralized exchanges. So it's an amazing story in terms of how composability or composable systems are way more efficient than traditional closed loop systems.
Yeah, it sounds like it. So I like to see things. I'm very visual. Is there, can you show us a demo of how DeepBook works, perhaps by sharing your screen and just make it tangible for folks?
Sure thing. Let me pick a window. Let's go. All right. Let me know if you can see my screen.
Yes.
Okay. So by way of background, if you look at this URL, this is deeptrade.wall.app. This is something we can cover later on, but this front end, this trading engine is actually hosted on Walrus, right? So it's called a verifiable front end. It's actually hosted on Walrus, but it's using DeepBook as a backend execution system. So for example, let's say I want to do a trade. I want to do a maker and a taker order, right? I'm going to put in an order in, approve my transaction, and then what you're going to see is a transaction shows up. So I'm now waiting for it to settle, but the actual matching is done directly on chain. It's instant. The next thing is I'm going to do an order that effectively should settle instantly, right? So I'll make my proposal, approve, and that's effectively done, right? So This is the same speed you'd expect on Coinbase, you'd expect on Binance. You're doing that directly on chain with SWI. The front end hosted on Walrus entirely. The back end is DeepBook ultimately as the engine. To add to that, because it's fully composable, anybody can build a front end for DeepBook. So this is Cetus, for example, in the DeepBook ecosystem. They've built a number of ways for you to trade. You could swap, you could do limit orders, DCA, and you can have DeepBook as an option where you could trade any number of pairs of assets. DeepBook has many markets that you could trade on, but ultimately anybody can leverage DeepBook as a composable layer. So Cetus is one of them that does exactly the same thing. So you get exactly the same experience you get with the centralized exchanges. Easy, fast, cheap, very low slippage, instant transactions. It's never been possible before till DeepBook and SWI were built.
This is awesome. Thank you for sharing this. So let's move over to Walrus now. Explain Walrus, how it works. Pretend I'm 5 years old.
Okay, so Walrus allows you to store large quantities of data that can have very flexible, programmable access control policies triggered by smart contracts, right? For example, let's say I want you to access this file. if you're part of my group or part of my club, or I want you to access this file if you have a significant net worth, or I want you to access a particular file on June 25th, when the temperature in New York is over 55 degrees. It doesn't matter, right? Like, you want to set complex rules around data access. Traditional systems struggle with that. They're really just baked and fixed rules. SWE with Walrus gives you an infinite number of configurations of how you may want to give access to data. And at that, large blobs of data. So you can store petabytes and petabytes of data on Walrus at very, very low cost.
And you started to touch on this, but what else about, why does Web3, when we've all used it, clearly there's a lot of daylight between what we think the user interface can be, and just from a data infrastructure perspective, what are you guys doing to improve that?
Sure. As you saw in the last demo, right? Like, Walrus isn't just data infrastructure. You can run entire applications on it. We don't think of Walrus as just data infrastructure. Web3 has never had flexible on-chain access controls and privacy policies that meet diverse enterprise needs. At the pure infra level, Walrus chooses it basically checks all the boxes you expect from modern infra. It has all the cost, performance, reliability characteristics that you're going to need for the most modern applications. It is far cheaper and far more performant and far more than what the last generation was offering. For example, Filecoin needs to have guarantee. It basically has no read guarantees, right? And it can take hours to download files. Arweave, you have to pay for 200 years in advance of storage, and last generation speed. Walrus is, imagine what AWS really could be if it's public infra, but with the flexibility of access controls and everything else that you may want to build. And any app can build on top of that, which we think is a breakthrough.
So on that note, talk to us about how Walrus works and what is the red stuff? Why is it such a breakthrough?
Yeah, I love the name.
Me too.
So
I wanted to make sure I got to say it on this webinar. Actually.
I know it's the red stuff for sure. Like, the key to red stuff is that it enables unlimited scalability. In traditional blockchains, for example, right? Like, every time you store information, you need to replicate it across every node. Let's say, for example, I've got a 1 gigabyte file. Well, guess what? If I have a blockchain network of 100 nodes, I need to copy that 1 gigabyte file across 100 nodes, which means it's going to be 100 times more expensive than storing data on just a single disk, right? So it's insane. Like, blockchains are not efficient for that. But what red stuff actually lets us do is it uses something called erasure encoding, which allows us to maintain a consistent 4 to 5x replication only. So it will take your file, break it up into millions, if not billions of fragments, but spread that across all machines in a way whereby your maximum replication is only 4 to 5x, which is actually what you expect from an Amazon or Google, where they replicate your data anyway. But the difference here is you only need to download the data from a third of a network to make sure it's correct. So let's say half the network is out. Well, you can still access your files. So it's higher resilience in centralized cloud, the same level of redundancy that you'd expect, but at the cost that you expect of enterprise. So it is an amazing breakthrough in design, an amazing breakthrough that you now have centralized grade technology, or like enterprise grade technology, offered as public infrastructure with amazing access and privacy controls that you care about. So it is, for us, it is one of the biggest breakthroughs we've made in the last 6 months on last year.
And what are some of the key use cases?
So a few things. Vendetta is a game. It's a fully on-chain game. It's a strategy game that uses, it encrypts the game state on-chain with verified Walrus and Seal. It basically stores high-quality AI datasets and gates access to it, which is a company called Inflective. TensorBlock effectively has models, memory, and agentic logic encrypted and stored. ZarkLab is building semantic AI search across private and public contexts. So datasets are stored on Walrus, and query level access is controlled. OneFootball distributes premium content, and IP is protected using Seal. CryptoGuard is actually, what we're calling one of the biggest deals when it comes to online security. We see the amount of hacks that happen. People go to websites, they click on a link, it's a wrong link, they get data stolen. We've seen billions of dollars lost in regards to website hacks. So Walrus is having something launched called CryptoGuard soon, which allows you to have a verified front end. So it would be impossible for your wallet to execute a transaction on a website that doesn't have a verified front end. So it's going to protect billions of users. So if you're doing your online banking versus you're just trading in DeFi, or versus just trying to order concert tickets, right? you'll be sure that your browser can ensure that you're ultimately safe and only engage with applications with verified code bases, which is a big barrier for a lot of users online.
We've talked about SWE a little bit. We've talked about these projects in the context of SWE, but Walrus has chain agnostic support. So how does that expand the reach to other chains?
Yeah, we have been engaging developers beyond SWE since last year, with Ethereum and Solana being the main focus. We have an HTTP API that's chain agnostic. For Walrus, we have partners that are integrating only with Walrus while remaining on a native chain. It doesn't require you to be a SWE maxi to use, right? It has applicability beyond Web3, and we think AI is actually going to be one of the biggest use cases. Interestingly, I believe more than a half of partners building on Walrus are actually doing something AI related, because it now is going to enable them to build like data markets directly on chain. So ability to sell your data, put guardrails behind your data, also decide which agent gains access to content that you want to give access to. In a world where robots are going to do majority of trading or negotiate on behalf of users, Walrus is very well placed for being that infrastructure that enables agentic trading of information.
Well, this is great. I want to zoom out a little bit and think about the bigger picture and get a little bit more philosophical. So how do DeepBook and Walrus enable next generation applications? What does it mean for a deep DeFi or social app to be built on each of these?
Yeah, it's a good question, because we feel like we've got there now, right? If you think about when we set out at Facebook to build this new stack, we wanted to empower builders to build really resilient applications where you don't need these laborious contracts to engage with a partner or third party, right? That the integration point really becomes the platform. So in the example I just gave you, where you have Deep Trade as a front end, DeepBook as a back end, right? DeepBook and Deep Trade, I mean, Deep Trade has nothing to do with DeepBook. It's really a front end, and leveraging DeepBook as a composable layer, anybody can build applications that fully interact with each other in the safest possible way. So you now have a marrying of people that want to build front ends on on Walrus. They want to build verified content directly on Walrus and gate it with interesting privacy controls. And then you have, of course, a SWE that has a flurry of applications that are all interoperable with each other using PTBs on SWE. So we believe the age of APIs need to die, right? The idea that you're simply just using APIs as a way to glue things. And I always say, when users have become the API, or the users have become the way in which you glue data from app to app, you have to enter your data in every different place you go to get context. Now, the app layer is going to be a lot more intelligent, right? It would leverage these PTB technologies we built as a way to directly integrate. And you could use Seal, SWE, Walrus, Nautilus, all that in a single package, unlike it's been available before.
And how do you think this works, and what role does it play in the context of scaling users, to the millions?
Absolutely. So like we always make the analogy, right? When you go to when you go to a website today, you do not say, wow, this website is amazing because it's running on Google, or it's rubbish because it's running on AWS, right? Like you have no clue as a user as to which flavor of infrastructure has been put together to make it work. In the same seamless way, we believe Walrus, DeepBook, and of course SWE will ultimately be utilities and not commodities. Namely, there'll be something you do on a daily basis where you end up touching one piece of our infrastructure, whether you like it or not, because it's key to how the internet works, right? So for us, it needs to be hidden away. It needs to be in the back end. It needs to be enabling better use cases, and it should not be in the front and center of users' faces. That's when you built real good infrastructure, where it can be hidden away and users actually benefit. So we believe we have the first piece of infrastructure where users can actually build end-to-end applications fully decentralized with very, very low cost, in addition to, of course, benefiting from all the composability aspects that SWE gives you as a platform.
And that's one of the things that we've been really excited about with respect to SWE, is that you're delivering Web3 in a Web2 format, in a way that we're used to interacting with Web2. How else does that look from a product perspective, and how does something like ZK login fit in, for instance?
Yeah, so the problem with Web3 is people have this idea that users need to start figuring out how to secure passkeys and typing in long phrases. Like if I go to an internet service provider, like nobody's asking me to type in passphrases and like that stuff just doesn't work for average users. It already costs you enough money to acquire a user, and then you're adding extra gates. So ZK login is a key technology we've developed that effectively uses the blockchain to verify your session with Google, Facebook, whatever service provider. So today in Sui, you can log in with your Facebook account to an application. You can log in with your Google account to an application. And that is done in a privacy-preserving way to allow you to do transactions. So Facebook, Google, other service providers will never know you're doing Web3. They will not be able to know the history of your transactions or even know you're engaging in Web3. It uses a complex technology called zero-knowledge proofs to work. It's actually the most widely used zero-knowledge technology in the industry, right? Because it's very consumer-centric. And the amount of wallets leveraging ZK login is increasing at a very, very rapid rate.
And that's a really big deal for those of us that have to write, are writing down our 12-word seed phrases on pieces of paper and locking them away in our like childhood homes. That's a big change.
Yeah, I mean, the big thing is like the blockchain itself verifies your session. It's not some third party that sits in the middle that takes all your information. It is a chain itself that does that in a privacy-preserving way that can verify Adeniyi is logged into Facebook, henceforth you gain access to his account and he can start trading. That is the key breakthrough that is very, very key.
And what else is Mysten Labs doing to bring more real-world users on-chain?
So the interesting thing is we believe now with Walrus that traditional applications can now benefit from Web3. If you want to have the ability to secure your front end and allow your user base not to be scammed, you would use Walrus and verifiable front ends. If you're building things related to AI and you want more accurate data and more data, more history around the data that you're using, you'd use Walrus for that, right? DeepBook is giving you the ability to trade traditional assets in institutional frame. We're going to have stocks and bonds and everything else eventually trade on DeepBook too. So you get institutional grade support, but in decentralized infra. And of course, Sui is powering all these underneath, right? So it's the partners are actually going to build the next generation businesses on Sui. They're going to, we could talk through partnerships as well, but the partners are already building amazing apps that would ultimately bring in these users, because what they could do in Web 2 is now being bettered by what Web 3 technology offers them with the Sui stack.
I think it would be great for people to hear a little bit about the partnerships, as long as it's not MNPI and it's public.
Of course, yeah. I'll talk about public stuff, right? Like, for example, in advertising, Alchemy are looking to disrupt the 750 billion global advertising market. They're already working with Coca-Cola, and major advertisers are signing up to the platform now. So they enable a more efficient data market so that ads are cheaper, but also reach the right user base. All leveraging Walrus and Seal and Nautilus and all the technologies we built. You can now build a more efficient ad exchange, leveraging the Sui stack that you can build before. This is all powered by Walrus. And of course, like we recently announced a partnership for Walrus, Evelyn AI, Yota Labs, TensorBlock, Flock, Gator.ai, Open Gradient, Talus, Atoma. Like the amount of AI partners on Walrus is increasing at a rapid rate. But this is an infrastructure we've always needed, right? Verifiable data is like a pinnacle. It's really central to building real models that are honest, but also don't hallucinate, but also solve real user problems. And Walrus is powering that. Yesterday, Seal became available on Walrus mainnet. With Seal, Walrus becomes the first decentralized data management platform with on-chain access controls. So Seal is Walrus's secret weapon. It has the potential to bring Web 2 enterprise with privacy requirements into Web 3 for the first time. Since Seal is integrated with Walrus at a protocol level, it also removes the need for complex privacy workarounds that some Web3 developers are having to work around. So there's never been a way to interact or integrate your trading system or your monitoring system with your data system, your payment layer, like all that into one, or your app layer. This is the first time with Walrus that's ever been possible. It's a big, big unlock.
And what are you most, like looking ahead, what are you most excited about going into the end of this year and into 2026?
Very, very simple. It's the convergence of enterprise IT security with AI and Web3. It is an area that we're very hot on the heels on, doing many things there, and we think Walrus is going to be key to making that happen.
Great. Well, it looks like we have some time. If you're okay, then I will take, we have some investor questions, so we can dive into those.
Absolutely.
The first one is, How does Walrus keep data safe?
Okay, so the erasure encoding and red stuff gives data durability and availability, right? Durable in the sense that we have ways to compute to make sure the data is what it says it is, and availability, ensuring that it's replicated in as many, I would say red stuffed in as many nodes as possible. So you only need to contact a small subset of a network to gain access to your data. So it is resilient to outages like traditional cloud service providers. The integrity of encoded blobs are also protected with checksums, which are organized in Merkle trees for those who are technical. But it is a highly resilient store that gives you the kind of security you'd expect from an Amazon, but the resilience that it doesn't offer you in terms of having a public infrastructure that's verifiable, that everybody ultimately has access to.
And so that's the security side. What about the economic model? How does Walrus incent users and create value?
Okay. Walrus, first and foremost, is powered by the WAL token, which users used to pay to store data on the network, right? When users pay for storage in WAL, they pay to have data stored for a fixed amount of time, and the WAL paid upfront is effectively distributed across time to storage nodes and stakers as compensation for the service. The mechanism ensures that both Walrus protocol is financially sustainable and that users can expect their data to be held safely forever. In addition to paying for storage, though, like Walrus tokens also ensure the security of the network, right? It's a delegated proof of stake system, and Walrus nodes compete with one another to attract stake from users, which in turn it governs the assignment of data to them. It is a system that is self-sustaining in that sense, right? I'd even like, if I had to even say one quote, right, from Gates, the CEO of Gate AI, like he said, today hyperscalers like AWS are extracting something like 40% operating margins from 80% billion in AI cloud markets, right? The centralized control system, it literally drives up cost. And as I was mentioning, now the fact that you have these composable systems, the integration costs are gone, right? Like you literally just plug into an on-chain, I would say, API. You can reduce those costs of interacting with any application or any data layer that you ever wanted. But ultimately, the economic model for Walrus makes it cheaper for anyone running AI models who wants to sell their data, who needs verifiability around the data they're issuing and trust elements around that data to do that cheaply. Now you can have a market where data is traded as effectively as trading Bitcoin or as effectively as trading, any kind of crypto that you want. Because you don't need to go and do the back-end audits that generally you do with traditional systems.
Yeah, and I think that's somebody else had asked about how it is so much cheaper and how it is so much more cost effective than the Arweaves and the Filecoins of the world. And I think that's sort of what you just covered. How are developers and users responding so far to DeepBook and Walrus? Will I need to understand the tech behind DeepBook and Walrus to benefit from them?
Good question. Interesting fact, DeepBook actually predates Sui. The team was working on the original iteration of DeepBook before Sui went live on mainnet. We're now in V3 of DeepBook, which has introduced a wide slew of improvements. It has seen massive validation from the Sui community, from broader DeFi ecosystem. The daily active users and daily volumes are increasing at a rapid rate. And of course, soon DeepBook is going to support margin trading, which is going to be insane, right? You can actually trade on margin on DeepBook. Walrus, on the other hand, is just getting started. It launched on mainnet in March 2025, and it's storing almost 600 terabytes of data today, and that's increasing rapidly. And the recent implementation of a technology called Quilt on Walrus means the cost to store large amounts of small data has actually been reduced by 100x to about 120x. So 100 kilobytes of blobs or 420 for anything 100 kilobytes or less, it's about 420x in reduction in cost.
Wow. Another example, this is more just speaks to the philosophy of, why we do things on blockchains or in a decentralized way. Can you give a simple example of a game or a social app or something within Web 2 that would work better because it uses these technologies?
Yeah, one example I'd always give is like today, if you're a content creator, your options for gating content is pretty much largely fixed by the provider you choose. So, for example, if you're on Facebook, right, there's a way it uses your social graph as a way to obfuscate information, right? And if you're on TikTok, it's some other algorithmic mechanism that gives access to data. Creators are going to want a lot more choice than that, which is why you have alternate platforms for publishing. With Walrus, you have an infinite means of defining how you get access to content, whether it's time-based, group affiliation, social graph, paywalls. The options are pretty much endless. There are opportunities to imagine new social media applications being built using these primitives, or existing large media platforms like Facebook and TikTok using external user behavior data. For example, trade history, video gaming record, because many gaming records are built on SWE, using that information to actually build more meaningful connections, data that they just don't have access to today, but users can volunteer and use to allow Facebook or Instagram or any of these platforms to allow you to build more meaningful connections online.
So I think that there's one more question, and it's just anything else, you want to talk about in terms of what you're excited about around what you're building at Mysten Labs today.
So I think the fact that DeepBook is going to have margin trading is a pretty much big deal. It's really going to elevate what's possible on chain. It's impossible to also overstate the importance of seal and what we call the SWE stack, right? Without data control, many businesses try to build on Web3. They fail, right? They fall on their face because there's so many insurmountable challenges, and seal removes that. Using SWE as a coordination layer and Walrus ultimately as a data layer, Seal provides programmable access control to protect any data you want. There's actually an app people should check out. Check out only-fins.wall.app. It lets you ultimately unlock content if you've gained a credential from Seal. So you can now start creating interesting rules to gate information. Actually, we're getting a few NFTs. You can go and unlock them today if you connect with the network.
I think I might just do that. So that's the end. That's all the questions. I want to thank Adeniyi for taking the time today. Thanks for joining us. This has been tremendously helpful. And thank you everybody for watching. If you have questions, you can always get in touch with us at info@grayscale.com. And I hope that everybody has a really great rest of their day and rest of their week.